Okay, so today we're going to talk about something new, something that we've been working at CIRA for the last 6 months. So it's fairly fresh off the press. It's a secure IoT registry, or a secure 5G IoT registry. And the information is on that link there, CIRA.ca/IoT. So all the slides you'll see and all the information that we have is pretty much public. So in the beginning of this summer, end of spring, we started to work with Spark on a IoT security acceleration program. And part of this is we were originally working on a home gateway project, and we discovered that there's a huge opportunity or a huge gap today in the 5G world in managing IoT devices. So we're .ca, we manage a .ca domain name. We've been doing that for 20 years. We're experts in registry business. And the thing we discovered is an IoT device is very similar to a domain name. And that a domain name, you can transfer the ownership of a domain name. You can transfer the registrar from GoDaddy to Wix. You can point it to different places. And then you can change the name servers and have the domain name point at different places on the internet. And CIRA, we're a registry. We're trusted to operate .ca for Canadians in Canada. So we have a huge infrastructure process in place to manage domain name. That's a mature business. Today, the way that IoT devices are managed, it's not like that. But what we discovered is that mobile IoT device, they could be managed like domain names. Meaning an IoT device the ownership can be transferred. So if we have a mobile IoT device, let's say a generic parking meter, a 5G parking meter, generic, the ownership could be transferred from the city of Ottawa to the city of Gatineau. The parking meter could be pointing to one cloud or an application service provider, like Parker Serve or Car Park Serve. Those are fictitious companies, but they can point somewhere in the cloud at different location. So there's many attributes of a domain name are similar to an IoT device, and that's what we're going to show today, and why can we do this today with mobile IoT device. So when we started this summer with the Spark project, the TELUS, BlackBerry, Solus, they developed a mobile IoT device using LTE-M cards. And in there's an embedded SIM, an eSIM. And on the eSIM there's a couple of attributes of that card that enable us to make this a flexible system in a way. So we had the IoT device, it's right there, it actually works. And in the demo that we do, it could be a live demo. The important thing here is the eSIM. So today, all the SIM cards, you get the little plastic thing you put in, that's the SIM card. Embedded SIM, it's a chip on something. So it's a chip on the IoT device. And because you can't put your mobile operator SIM card in it, the mobile operator has an opportunity to write their profile on the eSIM. Meaning, if it's a TELUS card, G+D embedded SIM, TELUS can, once it discovers the SIM on the network, it can write a profile, a service profile on the eSIM. So they write that, and they have the mobile operator, they have an orchestration platform to do all of that stuff. So what we're leveraging is inside the service profile for the mobile operator, there's containers. They're called IoT security applets, and we have the ability to write stuff in there. And the writing the stuff is what made this entire IoT registry possible, and it made the possibility in the future to have generic IoT device and generic cloud provider and point any IoT device to any cloud provider on the internet. Just like the way the domain name works today, you can buy a domain name and bring it to the registrar you want and point it wherever you want. That flexibility with the IoT device. So the kind of stuff you want to write in the IoT device are, what's the URL that you want the application to connect to? I want to connect to Car Park Serve, whatever. What's the port number? And what certificate do you need to connect to prove you're an IoT device? So that is the thing that gets, that we have the option to write on the SIM card. All right, we can see that. So if you look at the mobile IoT device, we have two service profiles there. The first one is for Parco Serve, and there's a URL, there's a port number, and there's a certificate. And if you put that in the SIM card, the application can read that and connect to that cloud provider. And then if you put the second set of credentials in the SIM card, on the eSIM, then it connects to the other provider, which is CarParkServe. So today, a lot of people, the industry is like the internet was before 1987. It was a big host file. So there was one host file, and all the computers, they had host name and IP address, and that wasn't scalable. So they built the DNS and they built a domain industry. I think today we're in the host file of IoT device. Because people will hard code their keys on the SIM, they'll get the SIM to work only with Amazon, and you have to use their cloud, or Microsoft, and you have to use their cloud. So there's a lot of hard coding today. Hopefully in the future, with this, you can make people that want to do IoT device do their business, and people that want to do cloud can do their business, and you don't have to do both. And today you're forced in doing both things, which is a problem. So that's the ecosystem. So in the domain name business, you have registrars, you have name server operator, you have registries, you've got hosting provider. That's well-established environment. In this environment, we have customers in blue. So you got a customer and they bought a bunch of IoT devices. They're mobile, they're 5G IoT device. Those are the blue. You have application service provider, like Parco Serve. That's our fictitious company, but they manage all the money on behalf of the city for parking meters, but they're a cloud application. We have mobile operator at the bottom, like the TELUS, the Bell, and all of that. And they have a orchestration platform, a system to push stuff directly on the SIM card. So if you look at this, we actually built a prototype to make all of this infrastructure work, and that's what we have in there. So what we'll do, is a quick demo. So we'll show, Andres from CIRA, very tough job here, is that demo. And we're going to demo what the application website look like, what the registry, the back-end registry would look like. I know it's hard to see from the back, but it's all, you can download these slides from GitHub on the other link, so it's all live. And what we're going to demo is we're going to simulate the city of Ottawa buying 1,000 generic parking meters, 5G mobile enabled parking meters, and they're going to, they did an RFP, and Parco Serve is the company that's going to manage those mobile operators, so those parking meters. So we'll simulate the provisioning of that, and then we'll show how it works. So the first thing that happens is when the city of Ottawa, they buy 1,000 generic parking meter, they have the list, serial number, part number, they have the SIM ID, the eSIM ID of all the parking meter, and all the public keys that are associated with all the parking meters. So they buy a bunch, install them, they get an Excel spreadsheet, I guess, and they have all that information. The first thing they do is they go to Parco Serve, and they set up an account there with this cloud provider, and they import the 1,000 generic device. So go there, and then you import the device, boom, 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 and then they get added with your cloud provider. So Parco Serve is an ASP. They have an API with the registry, and then they submit 1,000 devices with the registries. In the registry, just like our domain name, we register them. Here we'll register every single IoT device, and who they belong to, SIM ID, with all the information they have. And then what we're going to do for each one is generate keys, certificates. We're going to generate a unique certificate to identify that each parking meter. And the beauty of this system is that the SIM card, an eSIM, is like an HSM, a hardware security module. An eSIM, they can do encryption, they It can do decryption, it can do signatures, validate signature, it can do a lot of stuff. So what we do is in the registry, we'll create a cert and the credential for the IoT device. We're going to encrypt that with the public key. We're going to delete that thing, the keys, with the proof of deletion. And then we're going to send that to the operator. Meaning nobody in transit can actually see the certificate and the information that was sent. And only that SIM card with that private key matching the public key can decrypt the package. So it's a secure transmission of credential to an IoT device. Doesn't matter who's the network operator, who's got tabs and can see things on the network, the IoT device can be securely provisioned like that. So we activate the device, we generate a bunch of keys, and then we take the package, we have an API with the mobile operator, and then we'll send that and activate the IoT device. So that's a secure transmission of a package over the network using the MNO, the orchestration platform, and that they write that directly on the SIM card. So now you got a so you'll see inside the IoT security applet, there's nothing, and then it gets transferred. The IoT device, they decrypt the package, and then the application can take the credential information, the cert, the URL, the port, and all of that, and it does a connection to the appropriate cloud provider. So all they did here is click activate, and all the IoT devices get provisioned. So there's, if you have time and patience, and you should, read all about DNS and DNSSEC. And so what we do, once we generate a certificate for an IoT device, in the DNS, for that SIM ID, you can validate that the certificate is a valid one. So instead of using chain of trust, instead of using root CAs to sign a bunch of certificates, here we use DNSSEC. It's an alternative way of managing a root for certificate, but I think for this, it's way more efficient. So now the IoT device can make a secure connection to the cloud provider, Parcoserve, and that's it. So here we have the certificate. I know it's pretty hard to see, but it shows that the cert on the IoT device is the same as a cert in the DNS, and you can do a DNS query for a cert, and you can actually compare both to make sure they're the same. So there's no, you can detect a man-in-the-middle attack with this. And then if we look in the registry, we got Parcoserve, all the same ID, and the status, they're active, and the keys are generated. So now this is cities. Happy with this provider, the RFP is done, and then they choose another cloud provider, and Parcoserve is the winner. So a normal instance, the city would have to go to every parking meter, touch them, change something to get them to connect to a different place. So this is zero touch. So the city, they change a cloud provider, so we're going to do a transfer. So in the same way that you do a transfer for a domain name, I don't know how many of you transferred a domain name here before. So you know what a lock code is, you have a code, you give it to the other person, and they can transfer. So you unlock your domain, they transfer the domain, and then you're done. IoT device, it's the same thing. So the city want to transfer from Parcoserve to Parcoserve. So first thing you do is you copy the hot code from the IoT device, boom, copy the code, and then we'll say with the new provider, Parcoserve, I want to transfer all of these devices from one provider to the other. So we put the hot code, confirm the transfer, boom. So now, if we click activate, now the Parcoserve went to the registry and said, I want to transfer these IoT devices from that provider to the new one. Here's the code, it's all legit. And then the registry will generate new certificate for every IoT device. And then we need to revoke the old ones. So all the old certificate that we generated need to be the status revoked, and the new ones active. And we need to push that directly to the IoT device. So same thing here, we generate a bunch of certificates, we encrypt them, we delete them, Our plans is to use the Crypto 4A appliance here, Ottawa-based. Bruno, raise your hand. So we're working with him to make all of this stuff work. It's pretty cool. And so we'll generate the cert. And then same thing, we just send them to the mobile operator, and then it gets copied on the IoT device. The IoT device reboots, reads a new credential, does a connection to the new cloud provider. So now if we look here in the registry, we'll see that all the previous keys for the IoT device are revoked. The new one are generated. So over the DNS, if you do a query for the certificate for the car park serve, they're going to show as valid, and then the home provider, they're shown as invalid. So instead of messing around with CAs and signing and having a revocation list for 1 billion IoT device, which will never work, as far as I know, this is the DNS. It works perfectly for this. We're reusing the DNS. We're not inventing anything new in it. And there's a built-in chain of trust to validate all this. So the registry, we track the status of everything. And voila, zero touch. We've provisioned, we transferred 1,000 generic IoT parking meter from one provider to the new one, just by clicking the buttons. Nobody had to go in the field. Nobody had to touch, open up a parking meter. Nobody had to mess around with keys and certificate and complex stuff. You just click 10 times and it's done. So the ecosystem, so to do this, CIRA is going to join is joining the GSMA organization to define all of these as standards. The reason we're doing this is I think this is the way to manage IoT device in the future. Because today, having every IoT device hard-coded to the cloud doesn't make sense. Some people are, like I said before, some are good at doing IoT device, some are good at building cloud, but today you're forced to do both if you want to be in that business, and it creates for a lot of bad situation, companies getting compromised because maybe they have a good device, but bad cloud, and it's a big mess. So we're going to define APIs between the registry and the mobile operator. We're going to define APIs with cloud providers or application service providers and the registry. So if you're planning to build IoT device as an application service provider, then you need to know that if you register IoT device, you need to go to the main registry to track that. If you're planning to build IoT devices, you need to know that if you have an embedded SIM, you can go in, read the cert, read the credential, and use that to do your connection. The certificate can also include information about code signing, so that there's a lot of information that can be pushed in there to make the security of the IoT device more to be better. And the key thing is the DNS to validate everything. How much? So quickly about DNSSEC. So in 2010-ish, the root of the internet was signed with DNSSEC, which is so what they do is they sign the root zone, so they have a public-private key PKI infrastructure, and they sign the zone. And DNSSEC is not encryption of the DNS, that's DOE. That'll be a talk for next year. But what it does is that for every record in the DNS, there's a signature. So if you do a query for example.ca and you ask for the signature, you can validate that the IP address for the name is authentic. Because a lot of people are doing man-in-the-middle attack, they're doing DNS spoofing, they're doing a bunch of bad stuff on the internet. DNSSEC was put in there to make sure that when you query a domain name or you query something in the DNS, there's a signature to prove that the answer you got is valid. And the way you do that is there's a chain of trust. So if you do a query in IoTregistry.ca in the zone, and you have the yellow box is you say, give me the public key of the IoT device in the yellow box. That gets signed by the IoT registry. The IoT registry is signed by the .ca zone. The .ca zone is signed by the root, and the root, the trust anchor is public with IANA. So you can validate the chain of trust for a certificate in an IoT device using DNS. And that's important because this is a real-time database in the DNS, and then you have certificates that are valid. You need to know the status, and if they get revoked, you need to know that they've been revoked as well. And there's a lot more you can do with this, or should be doing with DNSSEC, but we'll keep it to this. So, like I said, so we're going to join the GSMA. We're going to build all these new standards. There's a lot of work to do there. And then we're going to be looking to partner with different organizations, most likely like Saint-Jean and others, and mobile operator, and to start building this framework. This is, if you never heard about this before, it's probably normal because it's about 3 weeks old, this story. Yesterday I was doing a presentation with a bunch of telcos, and they said, how come nobody told us about this? Well, it's new, so. There's a lot of innovation in this. The solution, we have a prototype that actually works. Not because of me, because of Andres and his team. But we were able to simulate the entire scenario. So in this IoT device that we built, when we push the config to connect to the first cloud, the car park serve, it actually does a cloud connect. It uses the Solus cloud, and then we connect with account A if you want, and we can see real-time the status of the parking meter if you push a button. And then when we push a second config, it logs its different credentials for a different Solus account. And then we use the MQTT to send the status of the IoT device. So there's prototype works. We need, it's new, so we need people to work with us in building making this. So we need IoT people to build IoT device to support this and cloud provider to work on this. And that's about it. So I got about 5 minutes for Q&A, if any. But you can go to CIRA.ca/IoT and you can find out information in there. The presentations are available on GitHub. And we have first question with Jordan.
Are the opcodes, is there some protection against reusing an opcode?
I didn't hear that.
Oh, so for the opcode, let's say there's the first parking company wasn't happy with the second parking company stole their customers. Is there something that prevents them from reusing their previous opcode to steal it back?
Yeah, well, that's what the registry is for. So you do 1-800-CIRA, you call and you prove who you are, and you can have access to them. But they should give it. When you provision IoT, when you want to transfer your IoT, let me start. There would be a certification process for application service provider. And in the same way registrars work today, if you want to transfer your domain from one registrar to another, you say, I want to transfer, you unlock the domain, they give you the hot code, and then we follow the same process. Oh no, after that you create new hot codes. No, they get regenerated all the time. Yeah, in the back.
So you showed a single mobile operator in your picture. So what if I've got, go from service application 1, cloud provider 1, cloud provider 2, but cloud provider 2 is with a different mobile operator. So how do I arrange for that to happen? Do I have to program all the profiles between TELUS and Rogers, or what's your answer there?
That's I think that's the beauty of the registry, is that you don't know which operator is going to be available where you put the IoT device. So when you do the first deployment, there could have been 99 on Bell, 50 on TELUS, and the rest on Cogeco. And with this, today, like I said, we live in the hard-coded world of IoT deployment or mobile deployment. deployment. So if you want to do you'll buy parking meters that are TELUS, and then they only work with TELUS. And then you got to make sure you install them in the zone that's TELUS. With this, you can potentially deploy your IoT device, and whatever telco picks them up, you can say you have a preferred deal with a provider using this, but if it's on another provider, you want it to come up. And what it does, the registry, is it bridges the gap between the telco and the end customer, so that in the end, like ParkOServe would take the money from the city of Ottawa, and then they would pay TELUS X amount per month for those that are on their network. They pay Bell and Roger and different telcos. So. No, that was that.
Can you talk a bit more about the crypto for a entropy as a service works? That portion of your schematic there, just like that.
There?
Yeah, the certificate of authority.
Yeah. So the key thing with this is you want to create a new cert for every IoT device, and you need to prove that the key. So we're using their appliance. The partnership is with them, and they have the quantum proof crypto appliance. And what we're looking for is we want to generate the keys. We're going to build an API with the appliance, so that when we generate the crypto material, that we encrypt with the public key of the IoT device, and we need proof of destruction that all of that information has been deleted, and that's what the appliance does. Bruno's there, you can talk to him on how he's going to do all that. Like, we're going to build an API, talk to them, and we're going to prove that we do all this stuff legitimately. So it's going to be made in Canada solution so far.
I was just curious, for that to work, the IoT device would need to have a eSIM profile that is compatible with that, so it would need to have its public private key encoded in there. Am I correct?
Well, typically, it doesn't matter where it comes from, but typically an eSIM, like G+D, will tell us would have a public-private key that comes with it, with the IoT device. Or the manufacturer might have built the IoT device with their own public-private key on the SIM, written in a container somewhere. As long as there's a SIM, a public-private key pair you can use to encrypt the credential. It doesn't matter if it comes from the telco or from the application, but it has to be on a service profile.
But the one from the telco wouldn't be shared with anyone usually.
Yeah. No, you can have the telco, the TELUS one, so you can have the PKI for TELUS to do their own stuff, but you could have, TELUS could write a separate key pair to be used for the IoT application. And that's what we would use to encrypt. All we need is, on the SIM card, is to decrypt something with the private key. So the public key is public.
Okay, thanks.
Any other questions?
One more question.
Do I have time or?
Yep, we're good. Just wondered how IANA key rollover versus backlist. What would be kind of
Key rollover? Not. No.
all the way down? All the way down?
No, the idea for this is that the IoT device, let me check
For DNSSEC.
so this one,
And I'm specifically DNSSEC key rollover.
yeah, the DNSSEC key roll would not impact anything. It's RFC 5011 compliant, so we would do that. And even then, the IoT device doesn't have enough, in our view, enough power, should not have, or might not have enough power to do validation. So the goal is, with the registry, to have a DNS over TCP, a dot name server, that would do all of the validation of the DNS on the CIRA recursive dot servers. You might have to Google that.
Jacques,
Question?
does this solution work transparently across existing mobile network operator cores, or there's some new feature dependencies?
Oh, we need to build the API between the registry and the mobile operator. But in the deployment of 5G, we need to do something like this. Andres and I spent 3 weeks, 3 days, 3 weeks ago at Mobile World Congress in LA. We were in the GSMA booth and we've done this demo a million times to a lot of big mobile operators, and they're all interested in getting something like this to work. So we need to participate with all the big players and make this work, but there's some standard development to do, specifically between the API, between the registry and the mobile operator, and also specifically on the SIM card, the profile, what's a standard on how we write the credential inside the SIM card. Then once we have that defined, then as far as I know, pretty much all the eSIM manufacturers are looking at implementing something like this. So there's a orchestration platform that needs to be able to send the data. And the application, we're going to need an API or a set of libraries for IoT device to be able to read the credential on the SIM card and decrypt and use that and the validation of that. So there's a lot of work to do still, but high level, we're pushing this concept. We're trying to see if there's any major roadblock in adoption. We haven't found too many or not yet, so.
Thank you very much, Jacques.
Okay.